Okay, so first of all, what happens is that we try to look at that why is it important? Why is it important to have requirements, to deal with requirements? We know that requirements define exactly what to build. We know why, so why do we even need requirements? It tells us what to build, and if we are able to fix a bad requirement, if we're able to know what exactly we wanted, if we got it wrong, and we got to know that later. Wait a minute, that's not even what we wanted to do. It basically saves us a lot of time and effort. And of course, if we even don't understand what we need to do and then we just go ahead and do it, in the end of the day, we make something that's wrong. And that's not what we want because it just costs a lot of money and it's a massive failure of time. And requirements engineering basically is like a process where it's like step and step process where we understand the stakeholders, the people who are interested in the our clients basically, and lower the risk of building the wrong product. So we understand the requirements so we don't mess up and make the wrong product. And it is split into 4 disciplines. For example, what we do is that we do elicitation, we do analysis, we do specification and management. We gather requirements, we understand them, we write them down, and we maintain them. That's the management side. We gather them, we understand them, we write them down, and then we maintain them. These are the 4 types. And if you look at the house building analogy, how a house is built, so requirements engineering is just like working like an architect. You gather the client wishes, that's elicitation. We're going back to these 4 terms. Elicitation is gathering clients' wishes. We evaluate costs and sketch plans, that's analysis. So we are evaluating the cost, how much is it costing us, and we're sketching the plan. So cost and plans. So we do that, and we write down official blueprints. That's specifications. What is exactly are we looking for? Like the blueprints, the official blueprints. And we track updates during the construction. Make a backlog maybe, write down, oh, this we did, this we did. It's like management to ensure the customer satisfaction. And that's the complete requirements engineering. And if we go into what is a requirement is a capability or condition that a user needs to solve a problem. So there's a problem that needs to be solved, and requirement is a condition that, for example, no, I am feeling hot. Feeling hot, that's a problem. The solution is turn on the fan. But the condition needs to be fulfilled that you're not feeling hot anymore. That's the requirement, that I don't feel hot. No hot. I'm feeling hot, that's a problem. And many people just talk about the problem. That's not the requirement. The requirement is that no hot, I don't feel hot anymore. So not feeling hot, not feeling hot. That's what I want. I don't want to feel hot. And that's the problem. I'm feeling hot. These are 2 different things. And I don't want to feel hot anymore is the real thing. And to be able to do that is a real important step than anything else. And that's the condition that we need to fulfill. And very rarely customers come up with the requirement itself. They might just come with a problem, and you don't have to give them the solution. You just have to solve the problem. And a system must meet a specific legal contract or standard, which is formally written down. This is the most important thing. It must be formally written down. Requirements are not from the air or what you assume is right. It needs to be something that is concrete and clear. You need to understand that clearly. And they need to be written down. That, oh, this is what I want, this is what I want, this is what I want. I don't want to feel hot. There should not be a list of problems or solutions. There just needs to be a list of things that need, or if they're not there, then you have to follow the 4 steps. And there are different ways you can extract requirements. That's something different. So where do requirements come from? So there are either project-based requirements or product-based software engineering requirements. So in project-based software, a specific customer brings you a problem to build a custom solution. So he just brings you a problem and he asks you for a custom solution. This is a specific customer. In project based, you build features for a generic user market. So it already exists, and there are generic users. For like a generic user, you build features for it, and to sell without one specific buyer in mind, and no specific buyer. So there is no specific buyer. It already exists, and it's just like a shop that already exists. There is no specific buyer for it. Anyone can come to the shop and buy, so it's open. But with a customer, he knows his customer, he knows who's gonna sell to, and he comes with a specific customer, brings you a problem to build a custom solution for their customers. So in this, they know their client, or they know their customers. In this product based, they don't know their customers. Don't know. I mean, don't know in a sense that it could be anyone. Of course, they know, like, they are human beings, or they can guess some things, but it could be anyone at any time, any part of the day, who would want a certain product. If it's lipsticks, if I have a business of lipsticks, I just sell them on a market, on open market. I don't know at what day, what time, who comes and buys it, but I can improve it, something that already exists. But with a project based, the person knows their customers, and they bring you a problem to build a custom solution. So a specific customer brings you a problem. So a specific customer, they already have a customer, and they are going to build a custom solution for it. So they know their problem as well. What are they looking for? How they can improve their sales. So they know, and they don't know how to improve their sales. Product based. And what are the 4 sources of requirements? Now, requirements come from 4 main places. It comes from system context, the stakeholders, of course. The system context, what are we talking about? Are we talking about lipsticks? Are we talking about mobile phones? Are we talking about laptops? Secondly, they come from the stakeholders, like users and developers, who are going to use it, like, are they users or are they developers? Other external systems or existing documents. These are the 4 different terms you can extract resources from, and extract requirements from. And when you're talking about what are the main challenges in dealing with these requirements, so the biggest challenge is that unclear objectives. We don't know what we need to do. High system complexity. It is very complex. Communication problems. You didn't communicate it on time. Constantly changing goals. Sometimes this, sometimes that, sometimes this, sometimes that. It's the same thing as saying that unclear objectives. Today I want no hot. Tomorrow I say no, I don't. I want hot. Or I say, oh, I want blue color phone. Tomorrow I say no, I don't want blue color. I want black color. So this is a real problem. Sometimes it's something, sometimes it's something. And losing the project knowledge over time. If the customer doesn't even know what he's talking or what is the project itself, he cannot come off with you with a proper knowledge, because he doesn't even have it, or he doesn't even understand his own project before he's defining his requirements. And there's something called elucidation, and let's go further in that. Why must you do current state analysis before target state analysis? What it means is that you look at how things work today, because users only complain about what is broken and silently assume everything that works well will stay the same, meaning that you risk leaving out implicit requirements. So they say that why you must do current state analysis. This is a current state, and that's the target state that we want to achieve. And we are trying to improve something that already exists. This is our current state, and this is the target state. Now, what we do is that we look at how things work today because users only complain about what is broken, silently assume everything else works well. So we must do current state analysis first. Then we need to do the target analysis. That, okay, is everything already okay now? Or maybe 3-4 more things are also broken. And that's, they say, oh, we want that. We want a phone with a better RAM. But what about RAM right now? Is it already good or is it already bad? Or maybe what about the camera and other things? And that's how, because people assume that everything is working. What if there are other problems that they have? And once everything that they assume, oh, everything's working well, and they stay the same, so we risk leaving out implicit requirements that were never told to us, that were never clear, that were sometimes causing the problem. So we need to understand that we need to extract requirements. First, we also need to do current state analysis, that how is it right now? That's really important. And what are the, so then we have, what are the main elicitation methods? Name them. So the main methods to do elicitation is an extracting requirements method, that we are trying to extract requirements. And we extract them through system archaeology. We will discuss that in detail. Document analysis, there must be document that they must give us. We observe through surveys, we ask them questions, interview them, ask questionnaires. Creativity techniques we do prototyping, we do current state analysis and target state analysis, and then we do team co-creation. All of these techniques we can use to extract the requirements properly. And they say, what are the advantages and disadvantages of system archaeology, like the document analysis? Why is it important? So analyzing old document is great because it is in sync. We know this happened, he wrote it, this happened, he wrote it, this happened, he wrote it. So as something is happening, he's writing it. So it's in sync. Then it uncovers forgotten rules. Sometimes we forget some things there should be in the document. But it's bad because it is time consuming, consumes a lot of time, and its paperwork might be outdated. So it might be really old and it doesn't work anymore. And it might work, but it's not relevant anymore. And if we compare the interview versus the questionnaire, what's the advantages and disadvantages? Is again an elicitation method that we said. Elicitation method. This is also an elicitation method, that we interview or we questionnaire. What's the advantage and disadvantage of this elicitation method? And this elicitation method is saying that we can interview goes deep and catches implicit knowledge, but are time intensive and hard to scale. So of course interviews can go deep, we can catch implicit knowledge, we can ask specific questions to our customers directly face to face, but they are very time intensive and they are hard to scale. We cannot scale them to multiple people. And questionnaires can scale easily. You can send a questionnaire to 50 people at the same time, to many stakeholders, but you miss hidden details and follow-up questions. You cannot ask one question after the other. In interview, you are open-faced, one after the other. Exchange is happening here and there. You ask multiple questions. In questionnaire, there's just a bunch of things that you send them. They can fill it out tomorrow or the day after tomorrow. You can send them a form and they can send you out that after 2 days. So what are the 5 interview questioning techniques, for example? So now we have some questioning techniques, interview questioning techniques. And these techniques include deep drilling, active listening, synthesis, which is basically summarizing everything that they have told us, filtering, prioritizing the important things and removing out unnecessary things that they're telling us, and parking, which means saving unclear topics for later. This is parking. So we have 5 techniques. What are they? Deep drilling, active listening, synthesis, prioritizing or filtering, and parking. So this is just explanation of what it means in the bracket. We have basically filtering, which means to filter and prioritize. And parking means to saving unclear topics for later. I don't get what you mean, and this is unclear, so I write it down, and then I will interview you again on this. This is what you can do in interview, because you're talking to the person face to face, one-on-one. Comparing observation methods, for example, field observation, apprenticing, and contextual inquiry. These are different observation methods. And field observation means watching silently without interrupting. So you sit down and you silently observe. You don't interrupt, you just observe. And apprenticing means watching and asking questions explicitly. You watch, but you also ask question if something is wrong. You interrupt, basically. And you ask questions. Contextual inquiry means the engineer actually performs the work to gain deepest understanding. So he actually does something. It's not talking, it's not doing, it's not asking question if something is unclear. It's not doing, and it's just doing the work itself to gain the deepest knowledge of it. That's contextual inquiry. And now we say that how are requirements classified? Requirements are grouped by what they do versus how well they do it. So there are functional requirements. Requirements are functional versus non-functional. For example, what do they do? What are the requirements? What do they do? Like, what are they supposed to do? That's functional. What they do versus how well they do it. That's non-functional requirements. That's quality based, right? What they do. Requirement is supposed to fill my bottle, for example. An automatic water bottle filler needs to fill my bottle. That's a requirement. Needs to fill my bottle. How well does it fill the bottle is a different thing. That's non-functional. Whether they're obvious, of course, it's given. User told us clearly in the documents. It's very clear. Or it's hidden. You don't know it. That's open or latent. And whether they are crucial, like for example, you must fill the bottle. It must do it. It must do it in 5 seconds. It must do it in 10 seconds. That's again a new requirement. Or it can do it in 10 seconds. It doesn't matter. It's just good. So functional versus non-functional. Let's go a little bit more depth into it. Functional requirements define what the system must do. Like for example, just like I said, like withdrawing cash. And non-functional requirements or quality requirements, just like I previously mentioned, define how well it must do it, focusing on speed, security, and technical constraints. This is more about how well they do it, how well the cash is withdrawn, just like I mentioned. How fast, how secure, how technical constraints, like how well it is technically, how secure it is, what is the speed of it. But it needs to withdraw cash. That's the first thing. The second thing is the non-functional. And giving the examples of non-functional quality requirements, for example, from Ludwig, we understand that quality categories are split into usability traits, the user's view, like reliability and simplicity, like he wants a simple UI, nothing fancy, nothing more. So quality, this is part of quality. How usable it is, how much I really want to use it. If it looks like shit, I don't want to use it. So this is the user view. Like I don't get to see that. Only users get to see how I design the UI. It's simple and sleek. And reliability, how reliable it is, simple it is. And maintainability traits. This is something I have to deal with. The developer's view, like testability and readability. How, like if I write a code for this, that I tested very well, it is readable, it is good, then it is good for me because it's the developer side. And that's something, even if the code is bad written, then it is not very good maintenance wise. It is not easily maintainable. And then we are going towards what are the 4 levels of abstraction for requirements. For example, requirements move from coarse to fine across 4 levels. Context, why, like why, domain, where, interaction, how, and system, what are these are the 4 levels. So these are the 4 levels where requirements go towards. We understand why are we doing something, what is the context of it, and we understand the domain, where are we doing it. We do interaction, how are we going to do it, and the system, what is the system itself that we're going to do it on. So we understand that these are the 4 different levels of abstraction for requirements. You can abstract requirements from this, that why are we doing this, so we can remember why, where, how, what. So the context, what is the context of it, That's the why. The domain is the where side. So basically we understand that, for example, we can look at the why part, that the bank needs to provide 24/7 cash and access to customers outside the branch and hours to reduce teller workload. That's why it exists. That's the context. And where it happens, the concept involves like the bank accounts, PIN numbers, and daily withdrawal limits, for example. And it happened in the real world. So the rules and the vocabulary, the real world actually, we talk about that. That's the domain. So the interaction is that how the user and the system talk to each other. So the customer interacts a PIN, inserts a PIN, for example, puts a 4-digit PIN, selects an amount, and then the system dispenses the cash, for example. And that's the interaction part. And the system is that what does the software itself must do internally to execute this, for example. The software must securely validate the PIN via API and decrement it in the database, for example. This is something that what the system does to actually achieve it. These are the 4 layers. And what are the 7 views of a system, for example? In that way, so basically, if you look at the users, we understand who uses it, who operates and who maintains the system. Everyday banks, customers, banks, and maintainer technicians. These are the users. Interaction, how the user and system exchange information. For example, the physical touch screen, the card slot, the printer, it interacts with, it comes out, the receipt comes out, and the keypad UI, you can interact with it, you talk with it. The procedure, the step-by-step process or workflow to get the result, for example. And that's like exact sequence. You insert a PIN. This is the procedure. You insert a PIN, you check the balance, you dispense the cash, and then you return the card. This is a sequence of steps that you follow. And this is a procedure how the requirement is fulfilled. And the data, the information the system must store, for example, process and manipulate. This is the data that it will store and process and manipulate. For example, customer account numbers, transaction logs, PIN hashes, and cash inventory levels in our example. And the 5th one is non-functional requirements. How well system performs, the security, speed, reliability, and that's the system must encrypt all data with EES-256, for example, handle transaction in under 3 seconds, and archive up to 99.9% uptime. These are different quality related things, right? And that's the non-functional thing. And now the surrounding is that, for example, we know the external environment or the hardware the system lives within. For example, the ATM is the physical armed ATM, the local power grid, and the bank's core network infrastructure. This is the hardware the system lives within. For example, just like I said, the physical armored ATM. So this is the ATM itself, like the physical thing. And that's the surroundings where it will be. And the local power grid maybe, and the bank's core infrastructure. So this is the environment where it will physically live. The constraint, for example, the unyielding limits, for example, legal, technical, imposed on the design. For example, compliance with banking regulations, compliance, a maximum hardware budget that we have, or using a specific legacy operating system. These are the constraints that we must follow. And in this way, we can also see that we can look at the artifacts and methods belong on the context level. What are these artifacts? So these are, for example, include product vision, for example. And what a product vision is that ultimate long-term core purpose and a high-level goal of the system. For example, it should create a secure self-service banking experience that allows customer to manage cash anytime, anywhere without entering a branch. That's the ATM, right? That's what the ATM is supposed to do for us. And what's the SMART goal? The SMART goals is that specific, measurable, achievable, relevant, and time-bounded business targets. For example, reduce in-branch teller cash transactions by 40% within 12 months of deploying the new ATM. So these are the SMART goals, that the moment we deploy the ATM, it reduced the workload up to 40%. These are smart, these are real goals. And then we have tasks, for example, that high-level businesses, activities, or objectives want to achieve in this environment. For example, withdrawing cash, checking account balances, depositing checks, or maybe changing an account PIN. So these are different kind of tasks or scenarios that are required. What are the different scenarios? Like somebody would withdraw cash, they will be checking account balance, they would be depositing, they would be changing a PIN. And then there will be scenarios, for example, real world stories describing how a user encounters and uses the system in context. For example, a traveler arrives at the airport late at night and realizes they need cash. And then they locate an ATM, and that's a real scenario. They came late in the night and there is nobody, there's only an ATM, and successfully retrieve the currency. And for example, the roles is that the distinct types of individuals or external systems interacting within this context. For example, these are different roles, these are personas, who's going to use it. So for example, a bank customer, or maybe ATM technician, maybe like central bank server, or someone who would want to use the system. These are different people who would want to use our ATM. And for example, in the terms of dictionary of terms, clear definition of domain languages to ensure everyone uses the same vocabulary. PIN needs to mean personal identification number. Dispenser needs to mean a certain thing, and everybody needs to understand what it means, and it's the same for every person. And that's what the glossary tells us. And after that, we understand what is a user story, give the template, and a good versus bad example. A user story describes feature from a user's view. As a who, I want what, to why. And based on this, we understand that what is a good user story. Let's talk about it. As a who, I want what and why I want it. So who, what, why. That's a user story. And a good example is something that stays solution free for now, and it's a customer point. And a bad example forces a specific technical solution, or any solution, for example. For example, if I say that as an ATM customer, I want to quickly view my balance on the screen so that I know if I have enough funds before withdrawing my cash. That's a good example because there is no solution provided here. He just wants to tell you what he wants and why he wants it. Who is he? He is a customer. He wants to quickly view his balance so that he wants to quickly want to see his balance so that he knows that if he has enough funds before he's even withdrawing it, like does he have enough money to withdraw it? That's why he's doing it. That's a good user story. But if you look at a bad user story, it might be, as an ATM customer, I want the system to run an SQL query joining the accounts table and print the output in 12 PT Arial font so I can see my money. And that's a bad user story because nobody understands that except for someone who needs to build it, but that's not really the point. It's not a good user story. If you look at what is a dictionary or glossary of terms and why is it needed, a glossary defines all project terms clearly to prevent communication problems and avoid nasty surprises caused by different teams interpreting basic words differently. For example, we know that in dictionary, PIN means the same thing across the whole project. If I say PIN, you know what I mean, and that's what's written. The full definition of PIN is written in a personal identification number. Personal identification number. It's a personal. It's not something different. It is what it is supposed to be, and everybody knows what I'm talking about when I say PIN. And that needs to be the same. So we ensure that we don't have miscommunication problems. What is a quality structure? And a quality structure specifies the exact sizes and capacities the system must handle, like peak user counts or which heavy drive architectural and performance decisions, for example. And what that means is that you cannot just say that, oh, I want to make a bridge, it needs to be strong. I need to define that what is the maximum weight it holds during rush hours, during demand, and how it withstands high winds, and how much it can withstand, the exact amount. For example, scalability is an quality attribute. So how much is the capacity and under maximum stress? How much can it take? For example, ATM must process 5,000 transactions per minute at max. This requires load balancing this is an architectural impact that requires a load balancer and a horizontal scalable backend service. Which technology am I using so I can make sure that this is possible? And it tells me about architecture, what kind of programming language or what tech stack am I going to use. I know the performance requirements that response time for example, cash dispensing must occur within 2.5 seconds after the user withdraws it. This is a requirement, right? It is a quality-based requirement that drives the database. This is a non-functional quality-based requirement, but it drives database indexing strategies and fast edge network routing. This is something I have to do as an architecture, that I have to make sure that I have indexing strategies or things like that. Now, you know what is the difference between a role and a persona? A role is a generic description of a group of people, while a persona is a detailed fictional profile of a specific representative with a name and a realistic data to help developers understand the users. And to get a clear difference between a role and a persona, we need to understand that a role is just functions the user group performs. For example, it's generic access. For example, any standard user can insert card and input a number, insert a card, input a number, a PIN, and can withdraw up to $500 per day. So it could be anyone, it doesn't matter who it is. So this is a customer. The role is a customer and he can do this. And a persona is a fictional character. For example, we have a name, we have an age, we have a specific, we have behavior, we have frustrations, who the individual is, how they feel. For example, an example of persona is that we have Oma. She's 74 years old, has poor eyesight and shaky hands, fears losing her card to the machine, and needs high screen contrast and large text. So we clearly know that there's a specific human being that we're talking about. This is too vague. It's just about standard people. Anyone could be a customer, but this is a specific customer. And why is documentation important in general? It is important because documentation forces precise thinking. We don't go all of the way everywhere. It's very precise thinking, builds a shared understanding across teams, so all of us think the same way. It's not so I make one document, I share it to everyone, and then all of us now know what to do. And it preserves crucial technical and legal knowledge, so it can be used for legal reasons. It is crucial and technical long after people leave a project, so we still preserve the knowledge. And that's why a requirement specification is important, and the benefits is that a written specification is baseline for deciding coding, user manuals, tests, planning, and final legal acceptance. As the rule says, there is no specification inside a persona's head. So now you must understand this clear thing that what now happens is that there, for example, design and coding phase. Let's look at that. Why the specification is vital? Because it provides the exact functional blueprint for developers to follow. And without it, like for example, a concrete ATM danger, what happens is that developers build a system that dispenses money before verifying the PIN, causes massive security leaks. So what happens is that when we know design and coding, it provides a certain functional blueprint that the developers can follow. And that's the benefits of a requirement specification. And a written requirement specification acts as a single source of truth for a software project. Without it, the developers and testers and stakeholders are just building entirely different systems based on memory and assumptions. And there's no specification inside a person's head. And based on that, for example, tests and planning. Then why is this specification vital? It gives us quality assurance engineers clear criteria to write tests. What is the criteria? And verify successes. If testers don't know if a 3-second transaction delay is an acceptable performance or a software bug, then it's a disaster, because they don't know if a 3-second transaction delay is acceptable performance or is it a software bug. Is it okay or is it not? It needs to be clear. And user manuals help, as for example, they serve as the accurate source text for technical writers to document features. And the help is that it tells users to look for a physical receipt button that the engineers remove from the UI. And that's really important, because if we don't have a user manual, we won't know that the help guide tells us that a user to look for a physical receipt button. And if he doesn't know this, then he will not be able to use it properly, because he needs to understand, if he has a user manual, then he can read it and know that engineers removed it from the UI, but it's there. It's a physical receipt. And then we have legal acceptance, and that acts as a binding contract to provide the software meets agreed conditions. And if without it, the bank refuses to pay the development agency, claiming they wanted an ATM that also accepts deposits. So we need to be clear about the requirements and legally bound them that they write it down. and they might change their claim that they wanted something different. So this is why these documentations are very important. These are requirements, specifications. Now we understand what is the difference between Lastenheft and Pflichtenheft. So Lastenheft is the client's view stating what they want and why. And the Pflichtenheft is the contractor's view showing how and with what they will implement those wishes. So this is the developer. And how will I do it? That's different. A very clear example of that would be the system. For example, Lastenheft is the client's view, right? For example, the system must allow bank customers to safely log in and withdraw up to €500 cash per day to reduce branch queues. That's Lastenheft, the client side. Like, for example, the bank. That's our client. We are working for the bank. What is needed and why? That's the core focus. And in Pflichtenheft, the contractor, for example, the software agency, how it will be built technically. For example, we will implement a card reader module using ISO 7816 standard, integrate a SHA 256 chip hashing algorithm, and connect the bank's core REST API. That's how we will do it. That's the technical side. That's the Pflichtenheft. And that's what makes it so clear for us. And if we get to know that Pflichtenheft reveals, this is our side, it reveals us that the project is 3 times more expensive than expected. And what happens is that you just basically reduce features to fit the original budget. You cut scope. That's what cut scope means. You remove the expensive, shiny features, and you just build a text-only cash withdrawal ATM. You raise budget. That's the second option. Client accepts the true cost and injects more capital. He understands, so you communicate that it's more expensive, and if he doesn't listen, then you can just cut scope or maybe just cancel if you want. The bank approves the 3 times cost increase because they realize the security infrastructure is required is mandatory. So the bank approves it. In our case, the bank is our Lastenheft, and we as software company are the Pflichtenheft. And I'm a developer, and the Pflichtenheft, the software company hired me basically. So we know that they must raise the budget or they must cancel the coding. Cancel the project means they kill the project immediately to lose further losses. The bank cancels the ATM project entirely. That's what the bank needs to do. We only communicate them. They can decide what they want to do from these 3 options. They can either cut scope, they can either raise the budget, or they can just cancel it. We give them 3 options. Now they decide if the bank cancels the ATM project entirely and decides to invest in the mobile banking app instead. That's possible. Or we need to do it before coding. We don't need to start coding now. Because if we do it, then we're losing 5,000 in planning hours just for a minor setback. Losing up to €500,000 in mid-development on a half-written code, which is a disaster. So what happens is that we understand that according to Paul, a comprehensive requirement specification is organized into 4 main pillars. It systematically moves from a high-level business goal down to technical execution. For example, introduction, let's say. The document, purpose, scope, and the target audience. That's the focus. So this document specifies the software requirements for the new ATM Fleet 2026 that is intended for developers and bank stakeholders. That's the introduction to it. The product context, vision, and processes. What that means is that the business environment, high-level goals, and core workflows. For example, vision is provide 24/7 self-service cash access. Our process is how a customer walks in, authenticates, and retrieves physical cash. This is all part of our product and vision. And it's combined with processes. Then we understand that technical system or requirements, use cases, for example. These are detailed system behavior, user interactions, and performance benchmarks. What that generally means is that withdraw cash scenario, quality transaction processes must take less than 3 seconds. Less than 3 seconds. This is again a technical thing. It's a quality related use case. Withdrawing use case is a withdrawing cash scenario. This is a use case. Withdraw cash on quality is less than 3 seconds. Withdraw cache in less than 3 seconds. And project requirements is the delivery timeline, budget limits, for example, testing phases and acceptance criterion. The beta software must be delivered by October 31 under a total development budget of 1,50,000 euros. So this is something that is clear to us.